Welcome to JavaScript APIs you've never heard of, and some you have. My name is Nicholas Zakis. I'm Slicknet on Twitter. Just a little bit about me before we get started. I'm the co-founder and chief architect of a startup called Well Furnished. If you're looking for furniture right now, please check us out at wellfurnished.com. I'm also the author of several JavaScript books. If you enjoy this talk, I hope that you'll pick one of them up. Now this talk is about JavaScript APIs that you probably have never heard of before. And that's because in the past few years there's been an absolute explosion of JavaScript APIs in the browser. A lot of these are in their infancy. We have new APIs that are getting a lot of attention, like Canvas and WebSockets, WebGL, drag and drop, File API. These are all very new, and so everybody's very excited about the power that they represent to web application developers. But the thing is, when there's this many APIs, it's a lot like having a bunch of kids running around. It's very easy to lose track of them. There are actually a lot of JavaScript APIs that have been implemented and are well supported across a variety of browsers that a lot of people just haven't heard of. And that's because there are so many new JavaScript APIs that these ones maybe aren't as exciting as some of the others. But that doesn't mean that they're not as useful. And so this talk is about the JavaScript APIs that are reasonably well supported across browsers, but maybe just haven't gotten the attention that they deserve because there are other cooler things around. The thing to keep in mind about the APIs in this talk is that they're pretty well supported across all browsers, and that means that they're ready to use right now. These aren't experimental APIs. These aren't things that you need to download a nightly build to use. They're safe to use in production right now because they're very well supported. So let's start out by talking about the DOM. And really, we're talking about HTML5, which you've probably heard of, has added a bunch of DOM extensions. DOM4, which is short for DOM Level 4, that's a new specification that's being worked on right now. And also DOM Level 2. There's a lot of DOM Level 2 that people aren't aware of. It's actually quite useful. And so all of the APIs in this section have to do with the DOM. Now the DOM is not a great API. It makes things a little bit hard most of the time. It's like having a speed limit sign with an equation on it. A lot of times we're left trying to figure out the right way to do things, and they're a little bit weird. The DOM extensions in this section have been designed to help with some of that weirdness. Now suppose that you have some HTML that looks like this. It's just a plain unordered list with 3 list items. Now you might stop and think that a DOM representation looks like this, where we have the UL, that's the parent node, and then 3 LIs as child nodes. Of course, that's not actually the case, because there are these text nodes that are in between them. So every bit of white space in between elements is represented by a text node. And so the first child of the UL actually isn't that first LI, it's a text node. And of course there are text nodes in between each of those LIs as well. And that's something that's been really annoying to deal with in the DOM for a very long time. And we're just starting to come up with ways to work around. The first new DOM extension to help with this problem is called Children. It's a property on all DOM elements, and it's part of DOM4. Children is an HTML collection of all child nodes that are elements, so it eliminates text nodes from the equation completely. It's well supported across browsers, and you don't need a vendor prefix to use it. So you can get a reference to the UL element as you would normally. And notice that child nodes.length is 7 because it's including the elements as well as the text nodes. Children.length, on the other hand, just returns 3 because there are 3 child elements to that element. You can also access the elements by numeric index, just like you can with child nodes. And notice that node1.nodename is text, because it's a text node and that came from the child nodes collection. But child1.nodename is li, because it's actually getting the first element that's a child of the UL. Now, one bug to be aware of course, is in Internet Explorer. Specifically, Internet Explorer 6 through 8 includes comments in the children collection. So just be aware of that if you need to support these older versions of IE. Because that basically means that in this case, the first child becomes a comment instead of an element. Just something to keep in mind. Another group of DOM extensions to deal with this problem is called the Element Traversal API. Originally it was its own spec, it's now being rolled into DOM 4, and this defines new properties for accessing element children. So you know in the DOM that you have first child that points to the first child element, and last child, which points to the last child element. And that's a problem because of these text nodes that get in the way. The Element Traversal API adds first element child and last element child that point to the first element that's a child and the last element that's a child, respectively. So you don't need to worry about text nodes there either. This is very well supported as well. Internet Explorer 9 is the first version of Internet Explorer that supports it, and you don't need a vendor prefix to use this in any browser. So first element child is akin to first child, and it's very useful so that you can skip over those text nodes if you just want to get the first child. Last element child, it's about the same. It's similar to last child, except it's going to grab the last element instead. You're also familiar with next sibling, which is supported in all browsers. That's just a standard DOM property. The Element Traversal API adds next element sibling, which lets you skip over any text nodes that are in between the elements. Likewise, going in the other direction, there's previous sibling in the standard DOM, and previous element sibling added by the Element Traversal API to skip over those text nodes in between. As an example, you can use this to iterate over the children of an element. You can continue to recurse down if you want to, but by getting the first element child, processing that, and then using next element sibling, you can progressively move through all of the child elements. Another DOM extension, this one doesn't have to do necessarily with text nodes and elements, is called contains. This is part of DOM 4, and it determines if a given element is an ancestor of another. Once again, very well supported across browsers, and you don't need a vendor prefix to use it. It looks like this. When you have an element reference, you can pass that into contains and see if that element is a child or descendant of another. So in this case, the element with ID of foo is probably inside of the document's body element. So if I say document.body.contains element, that should return true, and then I can do something with that information. This is very useful because a lot of JavaScript libraries have an isAncestor function or something similar that allows you to figure out if an element is an ancestor of another, and you can implement that fairly easily using contains. And that's very useful for event delegation. So if you have a click handler at the document level and you want to be able to tell if a click has occurred inside of a particular element, regardless of bubbling, then using contains is very helpful. It's also very useful for drag and drop to be able to tell if you're interacting with a particular element inside of another element. It's a very useful method. Insert adjacent HTML is another DOM extension. This is defined in HTML5. And this inserts an HTML string into the DOM at a specific place. You can think of it as inner HTML plus a location, because it takes an HTML string and parses it into a DOM before inserting it into the DOM itself. Once again, very well supported across all browsers. You don't need a vendor prefix to use it. And the syntax looks like this. The first argument is the location where you want to insert the HTML, and the second is the HTML itself. So the location is a string, which can be before begin, after begin, before end, or after end. And the HTML, of course, is just any valid HTML string. Now, to give you a better idea about those various locations, consider this piece of HTML. It's just a simple site menu with navigation. So if I get a reference to that menu, the UL element, and I say insert adjacent HTML before begin, that inserts the HTML before the menu element. So before the beginning of that UL is where that HTML is going to be inserted. Before begin is short for before the beginning of this element. After begin means after the beginning of this element. So the new HTML gets inserted basically as the first child of that element. You can think of it as like a prepend child. Before end inserts the HTML before the closing tag of the UL element. So this is very similar to append child, except that it can add multiple children and it takes an HTML string instead of a DOM element. And the last one, after end, occurs immediately after the UL element, essentially as the next sibling to that element, or the next multiple siblings to that element using the given HTML string. So this is just another way of inserting HTML into a document aside from inner HTML. And as a bonus, in many cases, insert adjacent HTML is actually faster than inner HTML. In some cases, they're very close, with insert adjacent HTML coming out just a little bit faster. In some cases, specifically in Firefox, it's slightly slower than inner HTML, but it's so slight that it shouldn't really be a consideration in whether or not you want to use this method. Another way of manipulating HTML is by using outer HTML. So a lot of people are familiar with inner HTML but have never heard of outer HTML. This is part of HTML5 and it lets you get or set HTML for an entire element. Once again, very well supported across browsers, and you don't need a vendor prefix to use it. The syntax is very simple, similar to inner HTML. You just set an HTML string into outer HTML property of an element. And that can be any valid HTML string. As an example, let's take a look back at the simple site menu from the previous example. So you can get a reference to that UL element and then get the HTML from that element by using menu.outerHTML. And what that returns is everything in the red box here. So that includes the opening and closing UL tags in the HTML, as opposed to inner HTML, which would give you only the LI elements. Outer HTML also gives you the opening and closing tags of the element itself. When you set outer HTML, it replaces that entire element in the DOM. So in this case, I'm setting outer HTML to another HTML string, and that removed the entire UL from the DOM. Now, the UL was removed from the DOM as if remove child was called. So this reference that I have to the variable menu is still valid. So tag name is UL, but its parent node has been set to null. That means you still have a reference to that original node even after you've set outer HTML. It doesn't magically change into a reference to the new HTML that you inserted. If you want to get a reference to that P element, you would have to go back into the DOM and get it manually. So just keep in mind that you now have a detached reference to UL that you can do something with, or you can discard if you no longer want the data. The next DOM extension is actually from DOM level 2, and it's called Create HTML Document. This creates an invisible HTML document in the page. The syntax is document.implementation.createHTML_document, and you pass in the title of that document. Now what you get back is a full-fledged HTML document that acts just like the document object. So you can create a new document and get its title just like you could with a regular document. You can set inner HTML on the body. The body is automatically added for you. You can use query selector or any other DOM methods that you want. Get your text content back. So this is really useful if you want to produce safe HTML strings. So in this example, I'm just detecting to see if the HTML string is safe by creating a new HTML document and inserting that HTML into the document body, then using query selector to see if it has any tags that I really don't want in there, like script, style, link, object. Of course, there may be many more that you want to test for, but this is just a very basic example of how you can quite simply look at some HTML using an invisible HTML document and figure out if it's safe to be inserted into the live document. A bit more complex, you can sanitize HTML in the same way, as if you get a reference to all of the bad elements that are in the document, you can then go forward and remove them and then return just what's left of the HTML. So in this example, I'm using query selector all to get all of those elements that I want to remove, and then using a simple for loop to remove each of them from the DOM. Then I'm returning what's left using inner HTML. Really handy to have around. You could picture loading HTML documents via AJAX as well, loading them into an invisible HTML document to manipulate them. This, once again, is very well supported in Internet Explorer starting in version 9, and no vendor prefix needed in any browsers. This next one has to do specifically with input elements. setSelectionRange is a method defined in HTML5 that allows you to select specific parts of text box content. So if you have a simple text box, you can get a reference to it like you would normally. Make sure that you set focus, because not all browsers will show selections unless the text box has focus. Now, if you just call select, which has been around for a long time, that selects all of the data, all of the text that's in that text box. Set selection range allows you to specify the range of text that you want to select in that text box. The first argument is the index of the first character to select. The second argument is the index after the last argument that you want to select. So in this case, set selection range 1, 3 actually just selects two characters, A and T, in the middle of that text. This is also very useful for positioning the caret. So you can put the caret at the start of the text box by saying set selection range 0, 0. You can also put it at the end by just using the length of the value in that text box. And that's very useful when you're automatically filling in values in a text box using JavaScript. You usually want to put the caret right at the end of the text so the user can continue to type. Along with set selection range, you have selection start and selection end, which lets you see where the selection is currently. So if you were to select just a couple of characters inside of a text box, you can get the values that were passed into set selection range by using selection start, which will return 1, and selection end, which will return 3. Now you can also use these properties to set the selection range as well, if you just want to change one of those values, either the starting position or the ending position. Once again, very well supported in all browsers, supported in IE as of version 9. Active element is also defined in HTML5, and that returns the element that currently has focus on the page. So you could select an element and set focus, but what happens if you lose that reference to text box along the way? Some other JavaScript is running in a different function that also wants to know the element that has focus. That's where active element comes in. All you have to do is document.activeElement, and that returns you the element that currently has focus on the page. Really useful if you're setting focus in a bunch of different places in your application. So focused will be equal to text box here, because that was the last element that was set to have focus. In this next section, I'm going to talk about XML HTTP request level 2. That's a specification that basically defines what we consider to be AJAX, the XML HTTP request object. Level 1 is something that everyone is familiar with. That's the interface that was implemented in Internet Explorer and later in Firefox and then other browsers. Level 2 adds additional functionality that's really powerful to the XHR object. The first is called form data. This is used to submit data as if it were in a form element via XML HTTP request. Now this has been a problem for a long time, where a lot of libraries have had to go in and create form serialization functions in order to allow you to do this. Form data allows you to submit data as if it's in a form element without going through that. So you create a new form data object by saying new form data, and then you can start adding key value pairs onto that object using the append method. So I've just added a few for this example. Now, the name is treated as if it's a form element, as if it's an input element on the page. So as if you had an input type equals text with name equal to name, or input type equals hidden with name equal to name. This is treated the exact same way. And then all you have to do is post that data someplace by passing it into the send method of an XHR object. Now by doing that, the XHR object automatically sets the correct HTTP headers so that the server will treat this as if it were a regular form being submitted. Now you can also use a form that's already on the page and wrap that in a form data object. So in this example, I'm saying document.form0, so the first form on the page, and passing that into the form data constructor. Now that automatically pulls in all of the data that is in that form so that I can submit that using an XHR object as well, just passing it into send. So you no longer have to go through the trouble of serializing HTML forms just to send it by an AJAX request. The really cool thing about form data is that you can also send files in this way. So let's say that I have a file element in a form, and I want to take the file that's in that file element and send it to the server. Using form data, all I have to do is retrieve a reference to the file. So that's done using the files collection on that element. File 0 is the first file that was selected, and I'm adding that into my form data object using append and calling that photo. And now I can just send the form data object as I did before. No special processing is required. All you have to do is call data.append and add a file there as the value, and it will just get sent automatically as if it were a file upload on any other HTML form. This is really powerful functionality, and it's available in all modern browsers. Internet Explorer 10 is the first version of IE that implements it, and Android 3, the first version of Android that implements it. But very powerful and generally really well supported without vendor prefix. There's also upload progress, which monitors the time to upload your request to a server. And so if you were to post something to a server, you can say xhr.upload.onProgress, and that fires continually as the data is being uploaded to the server. Now what you get in the event object is a loaded property and a total property. And these are both the number of bytes. Loaded is the number of bytes that have already been sent, and total is the number of bytes that will be sent. And so by dividing those and multiplying by 10, you can get a percentage of how far along your upload is, and then update some progress meter if you want. This is similar to the way that Gmail works with automatically uploading your file attachments for emails. And then just send your data as normal, and the progress event will be fired continually. The next feature is timeouts, and this is used to stop a request after a certain period of time. So let's say that you're making a request to the server, but you know that this might take a little bit longer than usual, and if it does, you just want to stop the request completely. Well, you can set a timeout in milliseconds by setting the timeout property on the XHR object, and then use the onTimeout event handler to detect when that timeout is tripped. Then just send your request as usual. If the request is taking longer than the specified timeout, it'll stop automatically, the request will be aborted, and the onTimeout event handler will be called. Now this is really helpful in today's chatty applications that are constantly going back to the server. You don't want to be waiting on the client for a response that is taking too long. And this is well supported in browsers, actually in Internet Explorer starting in version 9. And once again, no vendor prefix needed. The next feature in XML HTTP request level 2 is called response types. And this lets you retrieve a particular type of object from the server response, not just text. Now you're used to doing some of this already in all browsers. So you probably are using response text when you get a response from the server and then doing something with that text. And that works for all types of responses. If the response was XML, you also have the option of using response XML. Now this is nothing new. This has been part of the XHR object from the start. If your response type is an XML response type, the browser will automatically parse it into an XML DOM and store that in response XML for you to use. And this isn't new. This has been supported in browsers for a long time. What is new is the ability to specifically set the response type. So there's a response type property that you can set to any number of values. And then there's a response property, not response text, just response. In this case, I'm setting response type equal to text. And so the value of xhr.response will actually be just plain text. It'll be the equivalent of response text. I can also set it to document, and that means that the response text will be parsed as if it's XML, and you'll get an XML DOM back. Once again, this is similar to response XML, except you're explicitly stating the type of data that you want back. You can also set response type to blob, which is a new type that's available in a lot of modern browsers for dealing with files and random binary data. So if you set the response type to blob, then response becomes a blob object similar to a file object that you get using the file API. This is really useful for downloading images. If you want to download an image and just use that binary data, let's say on Canvas, or to create an object URL in the browser, blob is the way to go. You can also specify the response type to be an array buffer. So array buffers, if you're not familiar, are the raw form of typed arrays in JavaScript. And typed arrays are becoming more commonly used for Canvas and WebGL. And so if you have some binary data on the server that you want to get into an array buffer on the client, you can specify the response type as an array buffer and then pass that directly into a typed array to have your binary data. Very, very useful. And these are all very well supported, once again, Android 3, IE 10, all the other browsers without vendor prefixes. And in the future, you'll also be able to set response type to be JSON, and xhr.response will automatically be a parsed JSON object. This is not currently supported in any browsers. It was just recently added into the specification, so look for that to be coming to browsers soon. That's all for XML HTTP request level 2. The next section is on using CSS in JavaScript. Now, as our web application UIs have gotten more complicated, we've had to do more CSS type stuff in JavaScript. And there are a bunch of APIs that help you do that. First is matches selector. This is part of selector API level 2, and it determines if an element matches a certain CSS selector. So let's say that you have an element with an ID of foo. You can say element.matchesSelector and pass in the CSS selector for the ID of foo, and that will return true. Of course, you can do more complicated ones as well, seeing if the element is inside of the body element and also has a class of bar. This is something that is really useful in the browser, especially with event delegation. Because a lot of times you're not entirely sure what type of element you're working with when you're using event delegation, and being able to check that element against the CSS selector is incredibly useful to make sure that you know what element you're dealing with specifically. This is pretty well supported across browsers, Android starting in 3 and Internet Explorer starting in version 9. Unfortunately, there are vendor prefixes to deal with. So in Firefox, you need to use Moz Matches Selector. In WebKit browsers, you need to use WebKit Matches Selector. In Internet Explorer, you have to use MS Matches Selector. And in Opera, you have to use O Matches Selector. So because of that, you'll need to use a wrapper if you want to use this function regularly. I recommend this guy. Now, Matches Selector will eventually be renamed to Matches. This is a recent addition to Selector API Level 2, this renaming. It works mostly the same way. When you get an element, you can say Matches and pass in a CSS selector. The difference is that you can pass in an optional second argument, which is the reference node. So let's say that I want to know if this element has a class of bar, but only if it's inside of a specific element. I can pass in that reference element as the second argument to Matches, and it will only return true if the CSS selector matches that element in reference to that second argument. This was really something that was missing from the original implementation. I'm glad that it's added. However, it's not supported in any browsers yet. Look for it soon. The next method is getBoundingClientRect. This is a rather verbose method that determines both the size and the location of an element in the viewport. This is defined in CSS Object Model Views specification. And the idea is that if you have an element in the browser, you want to be able to get the rectangle that it's drawn in. And that means you can get a left and top, which you're probably used to working with normally, but also the right and the bottom coordinate. Now this is different than the CSS right and bottom properties because these measurements are made from the top and from the left, whereas the CSS properties are actually made from the right and from the bottom. So that's something important to keep in mind when using getBoundingClientRect. So how do you use it? You call that on any element that you have a reference to, and you get a rect object back. And you have rect.left, top, right, and bottom. Once again, right is relative to the left side of the viewport, and bottom is relative to the top of the viewport. All of these measurements are in pixels. You also have rect.width and rect.height, which gives you the size of the rectangle that this element was drawn in. One thing to keep in mind about these measurements is that they can be sub-pixel values, so they can be floating point values and not always integers. That's important to keep in mind if you're going to be using these values to make changes via CSS later on. Now there is a bug in Internet Explorer. Not too bad because it's in Internet Explorer 7 and later. It was fixed in version 8. Those older versions of IE actually add 2 to each coordinate of left, top, right, and bottom, and you have to subtract those manually. If you're dealing with IE 8 and later, you don't really have to worry about it, but it's important to know nonetheless. The next method is element from point. This is also described in CSS object model views. This returns the element at a given position in the viewport. So you can pass in an x and a y coordinate. So again, that's relative to the viewport itself, not relative to the page. And that will give you the element that is at that point in the viewport. So you should think client X and client Y on mouse events for these values because it's relative to the viewport itself. Now the element that's returned is the element at the highest z-index at that point. So if you have elements that are overlapping, it's always going to return the element that's with the higher z-index. So let's take a look at an example for that. This example has multiple divs placed sporadically around the page. And as I move the mouse, I'm calling element from point and using the values that were passed in. And as you can see, and I'm moving around the document, mostly it's the HTML element. As soon as I go over one of the divs, I'm getting that element, and I know that it has the correct ID. And this happens automatically as I'm moving through. Now div 3 overlaps div 1, and you can see as soon as the mouse gets to that point, it switches over, because div 3 has the higher z-index from div 1. So it's a really useful tool, especially in games if you have to do hit tracking or with drag and drop. Really useful to figure out exactly where an element is located on the page or what element you might be interacting with just by virtue of where the mouse pointer is. The last method I'm going to talk about today is match media, which is one of my favorites. This is defined in CSS object model views, and it allows JavaScript to interact with CSS media queries. Media queries are becoming more important as web applications move to responsive designs that automatically adjust depending on the device being used to view it. That's really great for layout and UI, but JavaScript sometimes has to adapt as well, and that's what match media allows you to do. You can call match media on the window object and pass in a CSS media query just like you would use in a CSS file. What you get back is a media query list object. It's not a Boolean. It's an object that allows you to interact with that media query. So first there's a matches property, which is a Boolean value that tells you if the media query is currently matching for the window. Now this value is automatically updated. So if you were to continually check matches, it will always give you the correct value. It's defined as a getter. It's not a static property. You can also add a listener for a media query by using add listener and passing in a function. Now that function receives the media query list object that is being triggered. And on that object, you can use .media to get back the media query itself that was passed in initially to match media. And then, of course, you can use matches to figure out if that media query matches. Now the listener is fired at 2 times. First is when the media query matches, so the first time that it starts to match. And the second is when it no longer matches. So as soon as max width 600 pixels is no longer relevant, the listener is fired again. It doesn't fire repeatedly. It only fires at those boundary conditions when you're changing from matching the media query to not matching the media query. Let's take a look at an example for that. This example is using the media query from the presentation, which is to check if the screen is at least 600 pixels wide. And you'll see as I shrink the browser that as soon as that is hit, the message changes. The screen is now less than 600 pixels, and it continues to show that message even as the browser gets smaller. And I go in the other direction, the screen is now at least 600 pixels and it changes back. And that's using that media query listener. This is pretty well supported in browsers as well. Internet Explorer 10 is the first version of IE that supports it, but you don't need a vendor prefix in any browser. There were also some bugs in earlier versions of Firefox and Chrome. Those are now long gone, and you can use this the same way in every browser without any problem. So we've gone over a lot of APIs today. Just to review the ones that we've talked about. The element traversal API that lets you move around the DOM tree by skipping over text nodes, things like first element child and last element child. The children collection that's available on Elements that lets you deal directly with element children and not worry about text node children. Element.contains, which determines if one element is a child or descendant of another. Insert adjacent HTML, which lets you insert HTML strings into a DOM in different places. Outer HTML, which lets you retrieve the HTML for an element, as well as completely replace that element in the DOM. Active element, which allows you to reference the element that currently has focus in the page. Create HTML document, which lets you create an invisible HTML DOM. Set selection range, selection start, and selection end. That lets you select only pieces of text inside of a text box. There's form data that allows you to use AJAX to upload data as if it were in an HTML form. Upload progress that lets you monitor your request as it's being sent via AJAX. Timeouts that let you stop an XHR request after it's gone past a certain amount of time without a full response. Response types let you specify how the data from the server should be processed when it gets back into the client. You can do text or blobs or documents or array buffers, and in the future you'll be able to do JSON. Matches selector, which lets you determine if an element matches a given CSS selector. Get bounding client rect, which allows you to get the rectangle of an element as it's drawn on the screen. Element from point allows you to determine the element with the highest z-index at a given point in the viewport. Match media, which lets you interact with CSS media queries from within JavaScript. And that brings me to the end of this presentation. I hope that you've enjoyed it. If you have any questions or would like to learn more, please check out my blog or contact me on Twitter. These slides are available on SlideShare at slideshare.net/nzakis.